Hello and welcome to a brand new geometry video. Hey, this video is about scale factors, proportion, area, volume, distance, similar shapes, all that kind of happy stuff. Well, might not be so happy because this topic really causes lots of headache for students. I'm going to ask you something ahead of time though. If as you're watching the video that you think that this video might be helpful for, well, somebody else, go ahead and click like. It'll help them find it when they do a search. And if you find it helpful for yourself and you want to stay, well, if you want to get notified and stay on top of new content that's coming out that would help you in school, hey, please subscribe. It's free. Why not, right? All right, let's dive in, shall we? If you ask your good old buddy Google, hey, Google, how many cubic centimeters are in a cubic meter? Well, it's going to tell you an answer that might be a little surprising. It's going to tell you there are 1,000,000 cubic centimeters in 1 cubic meter. But if you go and ask, hey, Google, how many centimeters in just a meter? It's going to tell you there's 100. That's confusing. 1,000,000 cubic centimeters for 1 cubic meter, but yet only 100 centimeters for a meter. That causes all kinds of confusion and problems. And even if you just remember that, but you don't understand why, it's going to get you into all kinds of trouble. All right, so the goal of this video is that you come away understanding two key things. The first is, well, I want you to understand why there are 1,000,000 cubic centimeters in a meter. Not just knowing it, but know why. Because if you know why, then you're going to understand, well, what it is you have to do and why you have to do it to answer a question like this one that's been, well, posed by our good buddy 3-Minute Maths. Well, he's not my buddy. I've never met him, but I do like his videos and I think they're quite fantastic. Anyway, if you had these two similar cuboids and you're given the volume of each and the area of one, by the time you are done with this video, you're going to understand exactly what to do and why to find the area of the other. So let's get started, shall we? Let's take a look at a line. Let's say that this line from here to here is in fact 1 meter. That's exactly the same as 100 centimeters. 100 centimeters, 1 meter is the same. Now you could describe the distance from here to here exactly with either one of those metrics. 1 meter, 100 centimeters. Now let's make a square out of this, right? So each side is going to be a meter, which is the same as 100 centimeters. We're going to make a square. Now the way you find the area of a square, you just take a side length and you multiply it by itself, right? So 1 meter squared is 1 square meter. We don't say 1 squared because that's kind of silly. Why would you say 1 squared? That's like adding 0. You would never say plus 0. 1 squared is 1. Now, if you talk about that same dimension, but now you use centimeters to describe it, well, now you got 100 squared. 100 squared is not 100. It's 10,000. So 1 square meter is 10,000 square centimeters. And another way that you can maybe understand that is from here to here is 100 centimeters. That's the distance. When you start talking about an area, for each one of these 100 centimeters, there's 100 more going this way. And that makes 10,000 square centimeters that fit inside of here. Let's talk about a cube now. If you take a cube and all the sides are 100 centimeters or 1 meter, and you find the volume of that cube, and the way you find the volume of a cube, you just take the side and you cube it. Well, you get 100 cubed, which is 1,000,000 cubic centimeters. But yet, 1 cubed is just 1. So 1 cubed meter is the same as 100 cubed centimeters. That ratio for volume gets cubed because volume is cubed. So let's see how that applies to doing problems like this. So let's say we're given two similar cylinders. Now in math, similar means something very, very specific. Similar means that the corresponding parts are proportional. Now corresponding, that means like relative same location. So like the radius of this is going to be, and the radius of this, those are corresponding parts because they're both radius. They're both a radii. Now the height of this is going to be corresponding to the height of this. The area of cylinder A is going to be corresponding to the area of cylinder B. The volume of cylinder B is going to be similar, or it's going to be corresponding to the volume of cylinder A. So corresponding means same relative location. It'd be like your left hand compared to my left hand, even though it says left hand and these are probably right hands. Either way, you get the idea. Same relative location. So now let's talk about what's going to happen. You're going to be given some information. You're going to be given information about corresponding parts, and you're going to be given one part for one of the shapes and being asked to find the corresponding part to that. So let's see what we're talking about here specifically. So let's say that we were given that the radius of cylinder A is 15 and the radius of cylinder B is 2. Well, we're going to be asked to use that information to find the height of A if we know the height of B. Or it could be the other way around. But in this case, let's say the height of B is 6 centimeters, and now we have to find the height of A. Let's talk about how to do that, shall we? But hey, before we jump in, well, if these are similar, that means that they're proportional. And if this is 15 and that's 2, then A is 7.5 times larger than B. So if the height of this is 6, the height of this is going to be 7.5 times larger. 7.5 times 6. Well, 7 times 6 is 42. Half of 6 is 3. 42 and 3 is 45. I think that the height's going to be 45. Let's go ahead and run you through the steps so that you can get that kind of answer even if the numbers aren't so friendly and easy. Let's see if 45 is right. So let's start off by what you got to do is you got to set up a ratio. You want your unknown first. You want your unknown value in the numerator. So because we know everything we need to know about B, but we don't know the height of A, we're going to put A in the numerator. Now we got 15 over 2, and now we have to use a proportion. And a proportion is just a pair of ratios that are equal. So because the A is 15, the radius of A is 15, but we don't know the height of A, those are going to be in the numerator, and the radius of B, of cylinder B, is 2, and the height is 6, all we got to do is set this up and solve it. Now, let's talk about why you want your unknown on top, because that's going to be, well, one of your best friends in this kind of problem. If you set your unknown on the top in the numerator, well, this is super easy to solve. All you got to do is multiply both sides by 6, reduce, you're done. But here, well, there's some shortcuts and some tricks, but they're not really math. And if you had a slightly more complicated situation, you could really get yourself into a lot of trouble if you start off with your unknown in the denominator. So do yourself a favor. Write the unknown in the numerator. Very, very important, because once you do, this is super easy to solve. All you got to do, like we said, multiply both sides by 6. And hey, we were right, 45. How you like that? Now let's try another one, right? So now let's say we still have that the radius of A is 15, the radius of B is 2. But now let's say we know that the volume of A is 512 cubic centimeters, and we're going to be asked to find the volume of B. Same way as before, unknown in the top. So here we know everything we need to know about A, but we don't know everything we need to know about B. So B's on the top. We go ahead and set up our proportion like this. Now, remember, well, for volume, even though there's 100 centimeters in 1 meter, when you talk about a cube, well, 1 cubic meter is 1,000,000 cubic centimeters. And so the reason that is because you're talking about volume, and those units get cubed. So you need to take the scale factor right here. This is called the scale factor. It's the proportion, right? And you have to make those units the same. So we're going to go ahead and we're going to cube that. And 2 cubed is, well, 8, and 15 cubed is 3,375. Now we got to do is solve this. Just like before, we're going to multiply both sides by 512, and we're done. 1.21 cubic centimeters, and that's rounded correctly to 3 significant figures, and we're done. So the thing everybody always messes up, the thing they forget to do, is they forget to cube it. And the reason you have to cube it is because we're talking about volume, and volume is cubed. So you got to cube that volume every single time. Now, because this is proportional, because they're similar, this one's 7.5 times larger than that. That means that the volume is going to be 7.5 cubed times larger for A than it is for B. And the area of A is going to be 7.5 times squared larger than B. That's how it works. Area is squared, volume is cubed. You got to remember to square area's scale factor and cube for volume. All right, now let's see another example, shall we? Now, even though the shapes look the same, let's say they're totally new, right? And let's say we're given that the volume of B is 216 and the volume of A is 729 cubic centimeters. And we're given the height of B is 12, and we now need to figure out, well, how tall is A? Same way as before, set up your proportions. since we know everything about B, it's in the denominator. Since we don't know everything about A, we're going to put it in the numerator, and we're going to set up a proportion. And just like before, because this is cubed, this is volume, and now this is a distance, well, this isn't going to tell us exactly the ratio of the heights because the units are all wrong. So we need to take this cube and we need to make it have an exponent of 1. And the way you're going to do that is with the cube root. Now you could use a calculator for this, but well, maybe you know that 9 cubed is 729 and 6 cubed is 216. So that's going to be 9 over 6. That could be reduced further, but I don't think it's going to be advantageous to do so because I think we can solve right here that this is going to be 18 because from 6 to 12 is twice as large. So this one is going to be 18. So in this situation, A is twice of B. There we go. So 18. Good to go? Now, what if, and this is where it's going to get a little tricky, what if we were given the areas and asked to find the volume? And this is perhaps the trickiest thing you're going to run into. If you want, you can pause the video. If you're feeling confident, pause the video. Try it on your own. See if you can figure out what to do. We got to get those units to be the same in that proportion. Go ahead and unpause it whenever you're ready. I'm going to get started right now. We're going to set up our ratio, unknown on the top, known on the denominator. So we got 400 to 81, right? And that's going to be equal to, well, we don't know what the volume of A is, but the volume of B is 316 cubic centimeters. Now, this one's not going to be quite as friendly as the last one for the numbers, but, well, we can go ahead and do this. Now, we have to figure out, though, how. How do we get these units to be the same? Now, it'd be really nice if there's a way we could do it all at once, but, well, we can do it one piece at a time if you want. Here's what you would do if you're going to do it one piece at a time. You would take that scale factor, and you'd take the square root, and that gets it into centimeters, and then you'd have to cube that to get your scale factor for volume, which is what you need because we're dealing with volume here. Or there's another way. Because square root is an exponent of 1/2 and we cubed it, we could take this whole thing right here and raise it to the power of 3 over 2. Boom, done. Get the same thing either way. And, well, you don't get any points for showing off this way, but it might save you some time. But if you're not feeling confident with that, you can do it one step at a time. So let's make sure we got this clear, right? We have area, which is dimension 2. We need volume, which is dimension 3. So to change an exponent from 2 to 3, we have to take the square root first, and then we have to cube it. That's how we're going to get this. So we're going to go ahead and now set up our proportions. So we got 8,000 cubic centimeters for A, and 729 cubic centimeters is the volume for B. We're just going to go ahead and solve this, and we're just going to multiply and reduce and correct, rounded to 3 significant figures. 3,470 cubic centimeters. So, why are there 1,000,000 centimeters in 1 cubic meter? And how does that affect, well, what is you have to do for these kinds of problems? Well, it's because volume is cubed. 100 cubed is 1,000,000. And when you're dealing with volume, your scale factor has to be cubed. When you're dealing with area, your scale factor has to be squared. So let's put this all together, shall we? If you're given the volume for similar shapes and you're asked for the height, do you know what to do? And if you're given the distance, like, say, a length, and you're asked for area, would you know what to do? Take a minute, think about it. All right, so here, check this out. If I'm going too quick and you're not ready, you're not done thinking, go ahead and pause it. Unpause it when you're done. If you're given the volumes for shapes and you're asked for the height, you set up your ratio of volumes and you have to take the cube root. That's the scale factor you're going to use. It's going to be the cube root of those volumes. That takes your centimeters or whatever parameter, whatever unit you have, like centimeters cubed. When you take the cube root, you just end up with centimeters, and that's what height will be in. Now, if you're asked for area and you're given distance, well, area squared distance is just an exponent of 1. So you'd have to square the scale factor before you set up your proportion that you can solve. That's it. So area, you got to make sure that your scale factor is squared. If you're given something that has a scale factor that's being cubed and you need a distance, you have to take the cube root. So putting it all back together, right? Distance is one dimension. It's an exponent of 1. And the scale factor needs to have an exponent of 1. For area, well, that's a dimension of 2, which is squared. Volume is a cube. That's a dimension of 3. So if you're given a scale factor that is volume and you need distance, you have to take the cube root. If you're given a scale factor that's squared and you need distance, well, you have to take the square root. If you're given distances and you can get a scale factor from that, and you need a volume, well, then you have to cube it. That's how it works. So here are some practice problems. I will put a link in the description down below where you can download these practice problems in a printable form. And if you're interested in this PowerPoint, because you might want to use it yourself, you might want it to review, I'll put a link in the description below where you can go to my website and download it and use it to your heart's desire. So once again, my name is Philip Brown. I am the Bearded Math Man. I hope you found this video to be helpful. And if so, please give it a thumbs up. If you want to be notified when new material is being released, hey, go ahead and click subscribe. And we got a cool podcast going on now. So please be sure to check that out if you're interested. Once again, I thank you for your time. Have a wonderful day.